Hey guys, welcome back to Math Homework channel. And today we have two problems on integration and the derivative. And also the integration problem, we're gonna learn how we find the point of inflection and the x-coordinate for this point of inflection for the function we're gonna study today. So let's start with, all right, it said g of x, that's the function, equal my limit from 3 to x, t squared minus 5t minus 14 dt. Okay, that is my function here. And he wants to find what is the x-coordinate of the point of inflection of g. So this function here, the g of x, I want, so imagine this function is like this. So, and this is concave down, concave up, and there is a point of inflection here. This is what we call it. So we want to find what is the x-coordinate for this point of inflection. Apparently there is an x and y value for this, but we concern about x value here. Okay, so this is how we, this is what's our target here. So, but first we have to just remember some rules. So when we have g of x is equal a to x f of t dt or dx. So if we take the derivative of this, that will basically cancel out the integration. So it's going to be equal to f of x. All right, so that's the first rule. Also if we remember, so when we say, if we have a function g of x and we take the first derivative, that will equal, basically give us the slope. In other words, it will give us is it the function going up or going down, depends on the value of the slope. And if we take the second derivative, which is d double dash of x, that will give us the upward or downward of the function, concave down or concave up, by finding the second derivative. Okay, or point of inflection. Okay, so now we lay down all the rules we're gonna apply in this problem. So the target is to get the second derivative, which is z double dash of x, and we make this equal to 0. In other words, we're saying that, okay, we're going to make this equal to, when the y value equal to 0 at the second derivative, then that's what will basically intercept with x-axis, and then we will be able to find out what is the x-coordinate at the point of inflection for this function. Great. So let's start with the first derivative. So g dash of x, so that's this function here, which is going to be equal. So we're going to take the integration away. So it's going to be x squared minus 5x minus 14. Okay, so that's the first step. Then g double dash of x is going to be, what's the derivative of x squared? 2x minus 5. And then we said we make this equal to 0. So x minus 5 to 0. So 2x equal 5. So x equal 5 over 2. And that's my x coordinate. So that is basically this value here for the function g of x at the point of inflection. All right, you got the idea? Great. Okay, let's have another problem here. The second problem, it's a derivative for trig function. So it's a d over d of x, x cubed secant 2x. Okay, so we have two functions, x cubed and secant 2x, trig function. Okay, so there's some rules also have to remember here. So we're gonna use product root. What this do when we have two function and when it gets the derivative, so we have to follow this rule. So d over dx u times v. So u times v, what is this equal to? So we say the first derivative, u, times the derivative of the second, which is dv, plus the second function, which is v, times the derivative of the second, which is du. But first, we have to assign u and v. So which is which? And we can say we're going to make the u is equal to secant 2x. So what's a du? Du secant 2x tangent 2x time my angle here is 2x times 2 covec. So that's u and v. So and then we're going to make the v is equal to x cubed. So my dv is equal to 3x squared. All right, great. Let's apply this to this problem here. So again, I'm going to follow this here. So we'll be, let's write it again. So we'll be equal to u dv plus v du. So what is the u? The u is secant 2x times dv is x cubed plus, dv 3x squared. Okay, plus v is x cubed times du is this expression here, which is secant 2x tan 2x times 2. Okay, let's clean this up a little bit. So that will be 3x cubed, x squared, I'm sorry, secant 2x plus, let's get the 2 next to here, so 2x cubed secant 2x tan 2x. And that's going to be my derivative for this 2 function. All right, there you have it. So please, if you like the video, just please like and share and subscribe for the Math Homework channel. Thank you very much.